that is adding probabilities. On the other side is multiplying, but we're only going to do the adding side. This is the homework assignment. If you need to write that down, go for it. It is there. Like 2 and 4 and 6, I think they all have like A, B, C, D, or ABC. There's just an ABC on each one.
Yeah.
But that still makes it like a lot of problems. So anyway, all right, adding probabilities. Let's do some vocabulary words. Here we go. I'm going to pick on this definition and this definition because they are similar to each other. The outcome that actually occurs versus the outcome you expect to happen. All right? I see two definitions over here that are kind of similar to each other. And they are theoretical probability and experimental probability. So what's the one that should happen, or what should we expect to happen? In theory, what should happen is what you expect to happen. So B goes in that spot, okay? The experimental probability is actually the result of what happens, right? What actually occurs. So if I have a coin and I'm going to flip it 10 times, in theory, how many of those times should show up heads? If I flip it 10 times, how many should come up heads? In theory, we should have 5 heads and 5 tails, right? But if I flip that coin 10 times, does that mean that it's going to necessarily come up heads 5 times always, right? It might be like 6 heads and 4 tails or something like that. That would be the experiment. In theory, it would be 5 and 5, but experiment might be like 6 and 4 or 7 and 3, right? All right, let's do another one. I'm going to pick on the middle one. Let's do the model used to represent the outcome of an experiment. I'm going to guess probability model because that has the word model in it. So a probability model. All right. Let's go down to the bottom one. A measure of the chance that a given event will occur. A measure of the chance that a given event will occur. I'm going to say probability because that's the chance of something happens. And then all outcomes are equally likely in a simple probability model. That makes it very simple that they're all equally likely to happen. Okay? All right. I'm going to go over here to this real quick. And we have, you can have a probability of something happening be 0 or like a 0% chance, in which case it's not going to occur. Not happen. You can have a probability of 1, which is 100% chance if we move the decimal and make it a percentage. And that is certain to occur. It's going to happen, like certain to happen, okay? Something that's as equally likely to occur as it is not to occur is 1/2 or 0.5 or 50% chance of something happening, like flipping a coin. I have a 50% chance of getting a head versus a tail. Okay? You cannot have probabilities that are negative. You probably knew that. You cannot have probabilities that are more than 100%. Right? Like there's not 120% chance of something happening, right? Okay, unless you watch Mean Girls. Anybody follow along with me? No? Okay, no. Whatever. Anyway, all right. So you can't have more than 100%. Now, I had Cody Hubble when he was a sophomore. Cody Hubble graduated. He's Kyle's older brother. When he graduated a couple years ago, he was like, wait a second, I've heard of percentages over 100%. And what he was talking about was like percent growth or percent increase, right? So like you have 14 of you in here, Chloe's here, there's 14 of you in here, and if I say you guys are a 200% growth over the class last year, how many were in the class last year?
You're in this class?
14.
7.
14 is a 200% growth over
7,
right? That means you doubled. You're 200%, so you are doubling, right? Does that make sense? Okay, so percent growth, you can have percentages greater than 100, but that's percent growth. That is not probability, okay? So that's what he was getting confused with. So if you're thinking about that, that's not the same thing as probability, all right? 0 to 100%, that's all we can do. All right, we have theoretical probability and we have experimental probability in this scenario. It says the graph shows the results of several trials of an experiment in which a single number cube or a dice is rolled, okay? All right, here is my result, all right? So I have a number cube or a dice. They always call it a number cube. I don't know why. We have a dice that has 6 sides on it, and we are rolling it a total of, I don't know how many times. Let's see. How many times do we roll a 1? According to the graph. 9 times. How many times did we roll a 2?
6.
6. 3 was 12. 4 was 6. 5 was 7. And 6 was 10. If we add all those together, too many to count. 50. 50 total. 50 total times. I'm going to say 50 rolls. Okay, let's talk about that 50 really quick. Each side of a dice should be rolled an even, like an equal number, right? So if we roll the dice 50 times, 50 divided by 6 means that each side should show up about 8.3 times, or about 8 times each should show up, right? So if I roll this dice 50 times, I should get 8 times where it shows up as a 1. I should get 8 times where it shows up as a 2, 8 times as a 3, and so on and so forth. And then 2 of them will end up being 9s, right? Like, show up 9 times. Are we confused? Okay? But that's not actually what happens. In theory, they should show up about 8 times a piece, right? But that's not what actually happened, because a 3 was rolled way more than that, 12 times. A 2 and a 4 were rolled only 6 times, right? So this is the experimental probability. This is the theoretical probability. In theory, it should be about 8 times a piece, right? But experimental probability is the other way. So let's answer these questions. It says, what is the experimental probability of rolling a 6? So how many times did I roll a 6? 10 out of a total of 50, which if we reduce is 1 out of 5. We just cross a 0 off, right? And that as a percentage, let me know, 20%, right? So 20% of the time we actually rolled a 6. As opposed to, how many times should we roll a 6? Or in theory, what? 8 out of 50. Or, if you just think about the sides of a dice, how many times should I roll a 6? 1 out of 6, right? Which is 8.3 out of 50. Does that make sense? Okay. 1 out of 6, which actually ends up being like 16%. So we should roll a 6 about 16% of the time. We're actually rolling it more than that, about 20% of the time. Does that make sense? Yeah? Okay. Theoretical versus experimental. Clear as mud? Are we doing okay? Okay. All right. Okay. Simple events is what we were doing. Now we're going to transition to compound events, which is kind of like what we were doing yesterday, where I would say we're drawing one card, and I want to know the chances that it's going to be a king or a queen. The chances that it's going to be a king or a spade, right? Those are compound events, all right? Okay, and more specifically, on your homework assignment, they're going to ask for whether they are exclusive or your book says not mutually exclusive, which I don't understand. I call it inclusive, right? We talked about that yesterday. So if you want to do that, or just say E or I, you can totally abbreviate on your homework assignment and make it a little bit easier, right? Like we like to save time, right? So exclusive versus inclusive. Okay, now why is a king and a queen exclusive? Why is it?
You don't have any.
Right, you can't have one card that's a king and a queen at the same time, right? Do you have a card that can be a king and a spade at the same time?
Yes.
Yeah, like the king of spades. They do a really good job with this Venn diagram showing you that. Inclusive means there's somebody in the middle of the Venn diagram, right? It could be both, right? So, inclusive versus exclusive. Okay, so we've got 2 scenarios down here. We've got to decide which one it is. Determine whether the events are mutually exclusive or inclusive. And then find the probability. Okay, so A says, Tashika's teacher is randomly assigning students a day to present their projects. Okay, I'm going to start listing information. If 8 students present on Tuesday, there are 5 that present on Wednesday, and there are 6 that present on Thursday. What is the probability that she will present on Tuesday, Thursday, blah, blah, blah. Okay, all right, let's deal with this information quick. How many students total are there going to be? 19, right? If we add all those up, 19 students total, okay? All right. Now, we have to decide, is this going to be exclusive or is it going to be inclusive? We're talking about days that you're going to present. So here's my question. Is there any way that you're going to present on both days? Or like Tuesday and a Wednesday or Tuesday and a Thursday? She's only gonna make you present once, right? Like that's enough, right? To present once. So it's gonna be exclusive because you're not gonna present on more than one day. Does that make sense? Okay. Exclusive. Okay, and we're talking about a Tuesday or a Thursday. All right, and I'm going to do a little Venn diagram here. Okay, how many students present on Tuesday? 8. How many students present on Thursday?
6.
And how many will present on Tuesday and on Thursday? None, right? So I'm going to cross that off because this is exclusive. So exclusive, nobody will be in the middle. All right, now let's talk about the probability. What are my chances of presenting on Tuesday? 8 out of 19 will present on Tuesday. Okay. Chances of presenting on Thursday? 6 out of 19. What do we do with those two? Add them because we're adding, right? Okay. And there's another thing in here. Do you see this word? We talked about him yesterday. That's where he shows up, right? Or means add. Okay. So 8 over 19 plus 6 over 19 is 14 out of 19, which won't reduce. If you do it as a, let's see, as a percentage, it's like 74%. Check that for me, would you, please? 73%.
Well, I guess no.
Would it round to 74? 74. 74. Okay, so it's about 74%. You, on your homework, you won't have to write it as a percentage. You can just leave it as 14 or 19. What, Logan? That was for A. I'm running out of room. Sorry. That was for A. Okay. Now for part B, there's a lot of information they give me. Whew, okay. All right. Suppose that of the 1,400 students, that's the total number of students that we have. I'm going to write that down. Total number of students is 1,400. 1,400. Okay. 550 of them take Spanish. 550. Okay. 700 of them take biology. And 400 are in both of those classes. So Spanish and biology. Okay? This is a lot. A lot of information. So, I'm going to draw a Venn diagram because I like to do that. Spanish, biology. Okay? There are 550 that take Spanish. There are 700 that take biology, and 400 is really tiny in the middle. Okay, is this inclusive or exclusive? Inclusive, because there's somebody in the middle. We can include those people. Inclusive. We can include the people that are in the middle because they are in Spanish and in biology. Okay? All right, now, before we answer this question, hold on just a second. How many students are in Spanish but not biology? 150, because 550 is the total, right? And 400 out of this is also in biology. So there's 150 over here that are in Spanish only. Does that make sense? How many are in biology only and not in Spanish? 300. You see how that works? Yeah? Okay, so let's answer the question. Here we go. What is the probability that a student selected at random takes Spanish, here's that word, or biology? Okay, so we're going to do Spanish, we're going to do biology, and we're going to add them together. Here we go. Spanish. What's the probability that I have a Spanish student?
150 out of 140.
Now, I'm going to do 550 out of 1,400. You might be able to get away with what you were trying to do, Remington. We'll go over that here in a second. So 550 out of 1,400 are Spanish. How many are biology? 700 out of 1,400. But we are counting how many people twice? 400. These 400 people are counted here and over here. So we got to subtract them out so they're only counted once, right? Subtract out the 400 out of 1,400. And that makes, I don't know, 850. Check me. Out of 1,400.
Yeah, please.
850 out of 1,400. Okay, if we reduce that, I know I can cross a zero off. if I divide the top and bottom by 5, 85 divided by 5 is 1, 7. 140 divided by 5 is 2, 8, I think. 17 out of 28. As a percentage, is it like 61%? 69%?
0.60. So 60%.
Is it
61.
61% is what it would round to. So about 61% of the students are taking Spanish or biology. Okay? Now, if 61% are taking Spanish or biology, what's the other 39% doing?
Taking both. No.
This includes the people taking both.
Other
The 39%, the other 39% are taking neither Spanish or biology. They're taking other classes like math and history and English, right? Because this number right here is anybody who's taking Spanish, taking biology, or taking both Spanish and biology. Does that make sense? That's this number. The remaining 39% would be taking neither of those classes, right? Okay. All right. Good. Question about that? Okay. You guys have a homework assignment, and if you have your book and want to open it up, I'm gonna do like a problem with you, quick. Let's talk about number 2 really quick. Number 2, I'll do like part A with you. Part A, because we got to talk about this. It's kind of confusing. 2A. I'm going to put this down. This is your very first problem. I'm going to help you do your very first problem. 2A. The question says on 2A, the probability, they write it as P, a sum of 10 or doubles. Okay, do you see that keyword? Or, sum of 10 or doubles. We're rolling 2 dice. So now I have this going on. I'm rolling 2 dice. And I have a sum of 10 or doubles. Okay. You can look up here on this board, or I'm going to write it down here because Chloe can't see the board right now. I'm running out of room. Where should I write this? I'll write it over here. Okay, if I am rolling 2 dice, I could get a 1, a 2, a 3, a 4, a 5, or a 6. I could get a 1, a 2, a 3, a 4, a 5, or a 6. You guys don't have to write this down if you don't want to, or you can if you want. So if I'm rolling 2 dice at the same time, I could get a 1, 1. Does that make sense? I could get a 1, 2, a 1, 3, a 1, 4, a 1, 5, a 1, 6. I could roll a 2 and a 1, a 2 and a 2, a 2 and a 3, a 2 and a 4, a 2 and a 5, 2 and a 6. Do you understand what I'm doing? Yes? 3, 1, 3, 2, 3, 3. All quit being annoying now. I'll leave this up on my board, so if you want to just refer to that, you sure can, or you can write it down. I don't care. It's a long list. Okay, be thinking of how many combinations are in this list. So that's what I'm going to ask you next. Did you figure it out? How many combinations or how many ways can I roll 2 dice? How many different outcomes can I get? What? 36. 6 by 6 is 36. There's 36 different pairs of combinations in there. Make sense? Right? Okay, now, if we're talking about a sum of 10, that's saying what outcome? What does it mean by a sum of 10?
Both dice equal 10 altogether.
Yeah, when I add them up, they equal 10, right? Okay, so let's figure out what combinations out of those will give me a sum of 10. Give me a combination. 5 and 5 is one of them, okay? 5 and 5 is a combination. All right?
6 and 4.
6 and 4 is another combination. 4 and 6. 4 and 6 is different than 6 and 4. Okay? 4 and 6 and 6 and 4 are not the same combination because you kind of consider it to be like the dice are 2 different colors, right? So like a 6 on the red dice and a 4 on this dice is not the same thing as a 6 on this dice and 4 on this dice. So if that's confusing to you why 6 and 4 and 4 and 6 are different, just think about them being 2 different colored dice. Okay? All right, so 6 and 4, 4 and 6. Do we have any other combinations? Okay, it was literally this one, this one, this one on my little mapping there, right? What do you notice about that pattern? It's the whole diagonal down, right? Do you see that? 6 and 4, 4 and 6, 5 and 5. Those are my 10s right there. Okay, so that's a sum of 10. All right, doubles. What are my doubles? What's a double mean?
1, 1, 2.
1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Oh, I'm running out of room. 6, 6. Okay? All right, can I roll a sum of 10 and doubles at the same time?
Yes.
Yes. What combination will give me that?
5, 5.
A 5, 5 combination, right? So, when I figure out this probability, what are my chances of rolling a sum of 10? How many combinations are there? 3 out of 36. I add that to how many combinations will give me doubles? 6 out of 36, okay? But then I have to subtract out one combination that's counted in both of those categories, and that is 8 out of 36. Or if I divide by 4, that would become 2 over 9. That's my chances. Does that make sense?
Leave it like that, or do you want the percent?
No, I don't need percent. So if you get to the fraction, that's perfectly fine. Was that confusing? Yes, kind of. Yeah. Yeah. Should we do another of that same one? Okay, so the next one that they say is, I'm going to skip B. You can do B because B is easier than C. So let's do C together. Should we do C together? A sum. What does C say?
Sum is greater than 3, or sum
That's
is less than 3.
sum less than 3, or, there's that keyword again, or
Sum greater than 10.
sum greater than 10. Okay? A sum less than 3 or a sum greater than 10. Okay, so I'm going to do my little Venn diagram here. We're going to list combinations of sum less than 3. Okay, sum less than 3. That means I'm adding them together and it has to be less than 3. All right, let me get rid of this. Ah, hold on. Hold on just a second. Okay, sum less than 3 is 1 and 2. Is that combination less than 3? No, that is 3. 3 is not less than 3. Okay, so 1 and 1 is less than 3. Anything else that's less than 3? No, it goes by the diagonals, just so you know. So 1 and 1 is a sum that's less than 3. That's the only combination less than 3. Are we confused? Are we doing okay? Okay, a sum that's greater than 10. So let me look at my diagram over here. Okay, give me a combination that will be greater than 10.
5, 6.
5 and 6. Okay, Remington says 6, 5, and 6, 6. What about like 4, 6?
No.
That is 10, right? That's not greater than 10. So there are 3 combinations that are greater than 10. They are 5 and 6, 6 and 5, and 6 and 6, right? Is there a way of me rolling a sum that is less than 3 on a dice and a sum that's greater than 10 on a dice in the same combination? No, right? So this is going to be exclusive. Do we have to label on the first one? Yeah, part A, we had to label. What is part A? Is that inclusive or exclusive? Inclusive, right? So maybe add that to your part A, inclusive. Okay? But part C is exclusive to begin with. Okay, now how do we figure out the probability of this happening?
1 out of 36.
There's one combination over here out of 36. We add that to
3 out of
3 combinations over here. And that is, and we don't have to subtract any, right? There's none in the middle. So that's 4 out of 36, which is 1 out of 9, right? 1/9? Yeah, it's fine. I've got calculus kids that can't divide, right? Ask Emma. 21 divided by 7 is 4 in Emma's brain.
Oh.
Makes sense.
Time you
Made
said
Megan,
that.
you made Megan
I was
think
like,
she was
hey,
dumb.
oh,
Made
I'm dumb.
Megan like heart drop a little bit. Anyway, how's that? Those are kind of tricky because it's a lot of like thinking. All right. Let's talk about the one right below that. So you'll have to do part B on your own, but the one right below that is number 4. Oh heavens. Okay, number 4. Let's do part A together and then I'll let you on your own. Okay. 4A. They give me some information before they have us do number 4. They say that there are, in a French class, there are 10 freshmen, okay? 8 sophomores, is that right? And 2 juniors, okay? Making how many total students?
20.
20 total students, okay? We're not talking about any seniors at all. We're just talking about freshmen, sophomore, juniors, okay? Total of 20 students. Of those 20 students, out of this 10 freshmen, how many of them are female?
9.
There's 9 females, okay? Let's draw some information from that. How many are males then? 1 male, right? Okay. How many of the sophomores are females? 2 females, which means how many are males? 6 males, right? Of the juniors, how many are females? 1 female, which means how many are males? 1. Do you see where we're getting these numbers from? Okay, they give me that there is 9 females, 2 females, and 1 female out of each class. So if there's 9 females out of 10, there's 1 male, right? If there's 2 females out of 8, there's 6 males. If there's 1 female out of 2, there's 1. Why did I write F? I don't know. One male. Got my label off. Okay? Lots of information going on there. Holy crap. A says, what's the probability of choosing a freshman or a female? Is that right? Okay, freshman or a female. Is that right? Okay, I'm going to do my Venn diagram. How many freshmen do we have? 10. How many females do we have? 12.
Take out freshman?
What? So we're doing freshmen and we're doing females. How many females do we have?
12.
Remington's right. How many total females do we have? 12, right? Do you see where we get 12 females? We're talking about just females, regardless of class. 9, 2, and 1 are how many females we have, right? So there's 12 females. Now, how many females are also freshmen? 9, right? 9 of the freshmen are females, okay? So, to do that, we do 10 out of 20 plus the 12 out of 20, and then subtract the 9 in the middle. Does this make sense? Yes, yes. So 10 plus 12 is 22 minus 9 is, Remington says, 13, and I believe him. That is that's just part A, okay? So, I'll leave this up here if you need this little information. This is kind of the breakdown of all those classes and stuff. Oh, was that inclusive or exclusive? That was inclusive, so you maybe need to label that. You can put just I or E if you want. That's inclusive because we have somebody in the middle, right? We have people in the middle, okay? All right? Okay, that was a lot. You may have more questions. You're going to have a question on number 6. We'll probably do that together tomorrow. We'll talk about that one. Okay, so anyway, try to figure it out if you want. But we'll do it together probably tomorrow. Okay? All right? Anything else for the good of the cause before I say bye to Chloe? No? You're just all sorts of confused? Okay. All right. Goodbye, Chloe. Maybe. Where's my... There we go.